Alright, this is lesson 91, hyperbolas, writing equations with given information. The goal for today, you're going to be writing equations of hyperbolas. So we're going to be looking at given vertices, co-vertices, I'm going to call them something different today, and also foci, and you need to take that information and go backwards and write the equation of a hyperbola. Okay. Here are the steps for today. The big idea is looking at the final answer, which is going to be either a major x or major y-axis hyperbola. The right one? No, that's not the right one. So again, looking at the final equation, is it major x or major y? All right. So, and if you look at the last answer, only three things you need to know are h and k, which is your center, a squared, and b squared. So if you know all three things, then you can write one of these equations, okay? So I'm going to do a couple of examples. Please watch right now, and then I'll give you an opportunity to talk and copy it down, okay? So, number one, vertices, they give us this information, negative 10, 1, negative 10, negative 19. The endpoints of the conjugate axis, which is another word for co-vertices, as the following, okay? And this is going to be the equation of a hyperbola. What wasn't specific there, but that's what it should be. So what I always like to do, and I always tell my students, is just draw a rough sketch of the graph, okay? So we're going to draw a rough sketch of the graph. We've got negative 10, 1, and negative 10, negative 19. So we're going to draw a couple points. Then we've got endpoints of the conjugate axis is 1, negative 9, and negative 21, negative 9. Okay, so once I know that information, I could draw like a little box, okay? So I know what this looks like, okay? So I know that the vertices are here and here. Therefore, the center must be in the middle, right? So I could calculate the center by finding the midpoint here like we did last time. But here's a shortcut. Look at the vertices. We know that the vertices are on the same line as the center, right? So since it's on the same line as the center, I know my center is going to be in the middle at negative 10 something, right? And I know it's major y, of course. So it's going to be at negative 10 something. But I know that the center is also at the same axis as these co-vertices or endpoints of the conjugate axis, okay? So the endpoints have a common number, negative 9, right? So you could easily find the center by going negative 10, negative 9, right? So our center is negative 10, negative 9. So I'm going to organize my info. Now I want to figure out what A and B are. So A is going to be the distance the center is from the vertice. So how far is negative 10, negative 9 from the vertice? You just count. We know this vertice is at negative 10, 1. So this one's negative 10, 9. So from here to here is 10 units. Or 11 units. Did I get that right? Yeah, 11 units. Did I do that right correctly? Negative 10. Plus another 1. Oh, it's negative 10 units. Okay. Right? Why am I not certain of myself? 1 and negative 10. 9. Yeah, that's right. Yep. Okay. Then we got to figure out what B is. B is going to be the distance from the center to one of these co-vertices. So from here to here, we know it's negative 10 plus another 1 is going to be 11. Okay, so I know it's major y. The vertices are here and here. It opens up and opens down. So I'm going to start with my knowing it's a major y, and I'm going to start with the major y formula, which is going to be y minus k squared all over a squared minus x minus h squared all over b squared. Okay, and I know that my h and k are going to be negative 10 and negative 9, so I'm going to have a negative negative, which is going to be positive, so it's going to be x plus 10 squared. My k is going to be y plus 9 squared. And then we said that our a is 10, so 10 squared is 100. So we'll fix that, that's 100. And then we also know that our b squared is 121, so we're going to write that down right here, is all equal to 1. That's how you do number 1. Okay? Again, You need three pieces of information to solve or to write the final equation down. You need the center, A, and B. In order to find the center, I suggest as a new, or if you're uncomfortable, is just write a rough draft picture of what it looks like. We found the center, we know that it's going to be on the same axis as the vertices and the endpoints. The vertices share a common -10, so I knew that this was going to be -10. Endpoints of the conjugate axis share a common axis of -9, so I know it's -10, -9, that's your center. The distance from the center to a vertice is going to be +10. The distance from the center to the endpoint of the conjugate axis is going to be 11. Once I had those three pieces of information, I could go plug them into this formula and we're done. Okay, so that's number 1. Questions on number 1? Okay, watch me do no. Yep. And if I know that this point is at -9, the distance from here to here is A, right? So from here to here is -9, right? So it's 9. 9 plus 1 is 10.
So you don't use the -10?
No, because -10 represents the distance from to move left or right? Does that make sense? Okay. Number 2. So number 2 is a little different. They give us vertices and the foci. We know that vertices and the foci will always be on the same axis together. So again, if you don't understand what the problem is doing, you need to just draw a rough sketch of what's going on. So 314, plot a point there for the vertice, and plot a point for 3, -2 for the vertice. Okay, since the vertices are up and down, I know already it's major Y, right? And then the foci are 3, 6 plus 8 rad 2, which I estimate is going to be a little bit past the vertice there, and there's going to be another foci underneath right there, okay? Again, this is not pretty or perfect, it just helps me understand. Therefore, there should be a center point right here in the middle, right? So I know that the center point right here in the middle is going to share the same common axis, or same common number, so vertices and the foci all share the same number of 3, so the center will contain the number 3. Then I need to figure out what's the midpoint between this vertice and this vertice. If this one's at 14 and this bottom one is at -2, how far is that? 16, right? 14 to here is 14 plus 2 is 16. 16 divided by 2 is 8. So 14 minus 8 is 6, right? So my center is going to be, common center is also 6, okay? The other clue you could get to find 6 is look at the foci. There's a 6 here, and there's a 6 here, right? Did you all see that?
Yeah.
Okay. But don't depend on the 6's here. I would suggest you just figure out what the midpoint is that way, because sometimes they are different. But for the most part on your work, it's going to be, you can find the clue here. Okay, so we have the center. Now we have to figure out if we have A, B, and C. So we're going to organize our information. The distance from the center to a vertice is A. So from here to here we said was 8. So A is equal to 8. I'm writing down my information. We don't have any common endpoints of the conjugate axis, so we don't know what B is. So we're not going to put down B. Okay, but C is the distance from the center to a foci. I know that one of the foci is 6 plus 8 rad 2. The other one is 6 minus 8 rad 2. So since that's the case, we know that C will be equal to 8 rad 2. Now I have all the information I need. I don't have B, so I need to solve for B. So I'm using the Pythagorean Theorem, a squared plus b squared is equal to c squared. Plugging in my information, 8 squared plus b squared is equal to 8 rad 2 squared. Okay, so 8 squared is 64 plus b squared. And then 8 rad 2 squared, we know 8 squared is 64. And then rad 2 squared is just times 2, right? 64 times 2 is 128. So I'm bringing the rest of the problem down. I'm going to subtract 64 on both sides. B squared is equal to 64 again. Therefore, B is equal to 8. So now I have the information I need. I know it's a major Y. It opens up and down, so I'm going to rewrite the form of the major Y hyperbola, at y minus k is equal to 1. Okay, I'm going to put an A here. Okay. And we're starting filling our information. We know H and K are 3 and 6 respectively. And then A squared is equal to 64, B squared is equal to 64. So even though we have a common A squared and B squared, we could assume that this is correct. Okay, that's it. Any questions on numbers 1 or 2? Cool. All right, so what I'd like you to do is ones or twos we'll talk today first. Twos we'll talk to the ones about number 1. Explain how do we figure out A or the center A and B, and how do we write the final answer, and then ones will tell the twos about number 2. Explain how do we find B from knowing A and C. Ready, set, and go. So we're continuing on. Number 3. Okay, so write down number 3 for me, please. We got vertices -7/2, 13. -7/2, -7, and then endpoints of the conjugate axis. They're giving us a couple points here. You can take a moment to write that down. I first try to draw a picture of what's going on, so I would draw the picture of the vertices. Now, on both of these vertices, we have -7/2, so you have to work with fractions. Sometimes -7/2 is equal to what? What's -7/2 equal to? What's that? 3.3.5, right? -3.5. Okay. Same thing here. We have 9/2 and 23/2. Don't let them phase you too much. We know that there's a common axis here of 3. So I know already that this is going to be a major Y example because the vertices are there, and these are my 2 endpoints. Okay. So based upon all of this, let's predict what the center will be. Okay, if you know that there's supposed to be a common axis right in the middle to find the center, what would my center be by looking at these points? Let's focus on these vertices. What's a common number on both of these vertices? -7/2, right? Because they all share a common number, so then my center must have -7/2 in it, right? Did you all get that? Did I have to calculate that? No. Okay. Looking at my 2 endpoints of the conjugate axis, what's a common number that's there? 3, right? So then my center has to have 3 in it, right? Did you all get that? So do you necessarily have to draw a picture to find your center? No. No. Okay. Now we have the center, now we have to find what A is. A is the distance from the center to a vertice. How far is it from a center to a vertice? If we know it goes up to 3, much farther to go up to 13? How far? 10, right? So A is equal to 10. Good. How far is B from one of these endpoints? Okay, we know this is -3.5, so from here to here is 3.5, right? How much farther is it from the y-axis to the next point? Well, if I know it's 3.5 from here to here, we know it's 3, right? Or I'm sorry, not 3. We'd have 9/2. So from here to here, we got 3.5, right? And then continuing on, from here to here, we got 4.5. So what's 3.5 plus 4.5? 8, right? So our B is equal to 8. This is going to be 10. Okay. So do we have everything we need to start off to write down our equation? Do we have a center? Do we have A? Do we have a B? What is it, major Y or major X? Major Y. Okay, so we're going to start off with the major Y form, Y minus K, all squared, all over A squared. This is supposed to say A squared. Is equal to 1. Okay, so we start plugging in our numbers. So H and K, -7/2 and 3 respectively. So this is where you have to kind of be a little bit careful. So we got Y minus 3, right? Because our K is 3 squared. Minus X plus 7/2 all squared. So I would start with your H and K first. Then we know A is equal to 10. What's 10 squared? 100, right? Then we have 8 squared. What's 8 squared equal to?
64.
64, that's right. I don't know what's going on here. Let me fix this. Oh, I see what's going on. Which is all equal to 1. Okay? So that's how you do that first one, okay? Questions on number 3. Was that hard? Okay, so sometimes you're going to have to deal with the fractions, okay? Number 4. Let me just give you an opportunity of doing this. What do you think the center would be if you know that the vertices are here and then we got some information here? Without drawing a picture, what do you think the center would be? What are the common numbers? Okay, one of them is correct. Think again, what's the common number? Turn to your neighbor and try to discuss. What would the center be? By looking at these points, what would the center be? Okay, what is it, everyone?
7 is 4 at 10.
Nope, just 7, 1, right? Does that make sense? Because the foci will always give you a reference of where your center is, right? Because we have to reference the foci, you have to reference the center. We know it's 7 plus 4, we're at 10. And then the vertices give us exactly where there's a common point, which is 1, okay? Okay, so how far is one of the vertices, focusing on the center and a vertice, how far is the center from the vertice? Looking at these 2 points. Discuss with your neighbor. Go. How far is it? How far is A? Okay, someone raise your hand. How far is A from the center? How far? 12, good. Okay, so A is equal to 12. And what is this, major X or major Y?
Major X.
We got 19, 1 and negative 5, 1, right? So it is major X, okay? A is equal to 12. What about B? How far is B? Do we know B? Did they give us endpoints of the conjugate axis? No, they don't. So we're going to leave that as a question mark. C, how far are the foci from the center? Not a trick question. The answer's up there. 4 at 10, that's right. Okay. So if that's the information that's given to you, do you think you could figure out what B is?
Yeah.
How do you figure out what B is? Put it in the what? Nope. Let's try not to draw a graph on this one. What's the formula? Good, the Pythagorean Theorem. So to figure out B squared, you have to use the A squared plus B squared is equal to C squared. Replace what A is and C is with the appropriate numbers we figured out. 12 squared is 144, okay. 4 squared is 16, right? What's rad 10 squared? 10, so what's 16 times 10? 160, right? Subtract 144 from both sides, we get B squared is equal to 16, therefore B is equal to 4, okay? Since that's, what are you doing? Since that's the question, or since that's the answer, we're going to plug in the following values.
No.
Oh, okay. All right, get to work.
See you guys.
Just making sure things keep on check. Okay.
I will.
All right, so write down the final answer. We got x minus h squared over a squared is minus y minus k squared over b squared is equal to 1. Okay, and then that's your final answer right there. Does that make sense? Yeah, you guys are all quiet, so good?
Yeah.
Yep.
How did you get A again? A plus 1.
A is the distance from the center to a vertice, so I focused on just the center and the vertices. 1 is a common point, right? Because that's the common axis, 1. So how far is 7 from 19? 12. Makes sense?
Yeah.
Okay. That's a good question. So do you always have to draw a graph? No. So once you get good at this, I wouldn't even draw a graph. I thought that this last one was the easiest one because I didn't have to draw a graph. Okay, that's it. This concludes the lesson.